Good day to everyone and welcome to week 3 of Statistics and Probability. For this week, we will discuss modules 8 to 10. So for the first module, module 8, it is entitled Interpreting the Mean and the Variance of a Discrete Random Variable. And here are the objectives. Interpret the mean and variance of a discrete random variable and recall and apply the formulas for the mean, variance, and standard deviation of a discrete random variable, which we have already discussed the second objective last week. For Module 9, of course, we need to solve problems involving mean and variance of probability distributions. These are the objectives. Of course, we need to calculate the mean and the variance of a discrete random variable, solve real-life problems involving mean and variance of probability distributions, and interpret the expected value or the mean value of a discrete random variable. Okay. So first, of course, there's a need for us to recall on the different formulas that we have discussed last time. So remember that if we have this symbol, the E and the X, so this is read as the expected mean, which is also symbolized by mu sub X. So mu or mu is the population mean, and that is equal to the X value times the probability of that plus your X sub 2 times its corresponding probability, and so on and so forth up to the last value of your X and the product of that to its corresponding probability. So in short, you need to get the summation of X and or the summation of the product of X and the corresponding probabilities. Okay, so that's the expected mean. Well, this one, so if we have here the squared, so this is the symbol used for the variance. And for us to compute for the variance, we have the formula summation of the quantity X squared times its probability minus the square of the expected mean. And for the standard deviation, of course, just get the square root of this and you'll have the value for your standard deviation. So these are the three formulas that you really need to remember in order for you to solve problems for this week's discussion. Okay, so I have here an activity entitled, What's the Formula? So you have to guess, right? So the following are the important formulas, okay? So let us take a look on situation 1. I am thinking of finding the average number of heads that would appear if I will toss 2 coins together twice. Which formula should I use? You have here the keyword average number. So if it deals with the average number, it means you are asked to find the mean. And from this 4 formula, the only formula for the mean is, of course, A. Okay, so you need to take note of the word average number. So if it deals with average, it means you need to find the mean. Let's have situation number 2. I went to the grocery store and I noticed that there are 5 different kinds of brown sugar at different prices. Each brand has different probabilities that they will be sold. What formula should I use if I want to determine how the prices vary, okay, from the average price of the product that would be sold to the customers repeatedly? So the keyword here is the word vary. How are the prices vary from each other? So if it talks on variation of something or any number, so which do you think formula applies to situation number 2? Okay, so you're correct. That is formula letter D. So remember the keyword vary or variation. How are the scores varied or how far away from each other? You need to find the standard deviation. Okay? Let's have situation number 3. Wala na pala. Okay. So proceeding with the next slide, here is your learning task number 2. Learning task number 2 is not recorded. Okay, so you can do this as an exercises for you to easily undertake modules 8 and 9. So suppose an unfair die is rolled and let x be the random variable representing the number of dots that would appear with the probability distribution below. Okay, so when we say unfair die, it means the probability of each number on a die is not equal. Because when we say a fair die, so each of the numbers from 1 to 6 will have equal probabilities. So in this case, since it's an unfair die, as you can see, the probabilities are not equal, although most of them has a probability of 0.1. So remember, one of the properties of probability, that the probability of anything must always be equal to 1. So if you will add these probabilities, 0.1 plus 0.1 plus 0.1 plus 0.5 plus 0.1 plus 0.6 is of course exactly equal to 1. So not less than 1, and not greater than 1, exactly equal to 1. Okay? And the outcome, or your random variable x, are the numbers on a die, okay? The dots. So question number 1, what will be the average number of dots that would appear? Average, meaning you need to find the expected mean. Number 2 question, how does the assumed value of the outcome vary from the average number of dots that would appear? So vary meaning you need to find the standard deviation. And third question, based from the mean and the standard deviation, will you join in a game of chance using an unfair die? Let's see. I have here the solution for number 1. Okay, so looking at the value of your x and the corresponding probability, in order for us to find the expected mean, remember the formula for the expected mean, because we will be using this in finding the variance. Okay, so here, for us to find the expected value, we need to multiply the x and its corresponding probability and get the summation of that. So 1 by 1, it's 1 times 0.1 is 0.1, 2 times 0.1 is 0.2, 3 times 0.1 is 0.3, 4 times 0.5 is 2, 5 times 0.1 is 0.5, 6 times 0.6, 0.1 is 0.6. And then all of this must be added for us to get the summation. So this is equivalent to 3.7. So meaning the expected value, or answering question number 1, that is equal to 3.7. And for us to find the variance, we need to have this column. So as you can see, I tried to square first the values of our random variable x. So these are the values, and then multiplied again to its corresponding probability, and the summation will be used in finding the variance. So remember, this 15.5 will be subtracted to the square of the expected mean. So 15.5 minus the square of 3.7, therefore, the variance is equal to 1.81. And in order for us to see how the dots in an unfair die varies from each other, we need to get the square root of the 1.81, and that is equal to approximately equal to 1.35. So 1.35, that is the value of the standard deviation and the answer to the second question. So by looking at these values, okay, answering question number 3, will you still join a game with an unfair die? Of course, hindi, 'di ba? Unfair nga siya eh. Yan. Okay. So now that you know how to find the expected mean, the variance, and the standard deviation, we will now try to interpret the variance and the standard deviation. If you can still remember in your grade 10, when we talk of the measures of central tendency, we have the mean, the median, and the mode. But when we say measures of variability or measures of spread, we have there the variance, the standard deviation, the mean average deviation, what else? Yeah. So variability or spread, okay? So how far are the scores from each other? So we need to have this two measures, the variance and the standard deviation. And here is our interpretation. Small variance or standard deviation means that the assumed values or data points tend to be very close to the mean, while higher values or data points are spread out from the mean, meaning in a certain distribution, it's always better to have a small value of your variance or your standard deviation. Why? Because it means that the scores or any value or any number tends to concentrate at the middle. Okay? So meaning magkakalapit sila. But if they have a greater value or a higher value of the standard deviation, it means that the scores or the numbers are quite far from each other. Okay? They are spread. They spread out from the distribution. Okay? So again, it's different from the interpretation of the mean, because if you have a higher mean means the better. But in the case of measures of spread, like the standard deviation and the variance, the smaller the variance, the better the performance. Or the smaller the standard deviation, the better the performance. So remember that interpretation. Okay, so I'll just skip this one. It's a comic strips. So in the module, you have also a copy of this, so you can try reading that so that you will know how to decide if you have a raffle ticket. Okay, malay nyo, manalo kayo sa lotto. So at least with this case, you can relate. Okay, so your first learning task for week 3 is entitled The Raffle Tickets. So you need to answer this and remember to show your complete solution. For math subject, I'm not always after with the correct answer, but more of the solution to the problem. Okay, so you really need to complete all the needed information, and at the same time, you need to interpret the value of your expected mean and the standard deviation if in case we don't have a standard deviation here, just the mean. Okay. Okay, and this one is module number 10, entitled Illustrating a Normal Random Variable and Its Characteristics. This is the last topic for week 3, and here are the objectives. Define a normal random variable, illustrate a normal random variable and its characteristics, and state and apply the concepts of the empirical rule or the 68, 95, 99.7 rule of the distribution. Okay. Let's try to listen to this video in order for us to understand clearly what a normal distribution is. Ayaw niya mag-play. I'll just be sending the link of this one for you to view the video and watch the video. Okay. So the video actually is all about the normal probability distribution. Okay. So if you don't want to watch it, most of the concepts that you can watch or you can get from the video is already written in my slides. Okay. So when we say normal probability distribution, it is a probability distribution of continuous, remember continuous and discrete random variables, anything that any variables obtained through measurement are examples of continuous random variables. So continuous random or the normal probability distribution shows graphical representations of random variables obtained through measurements. It is used to describe the characteristics of populations and help us visualize the inferences we make about the population. It is also used to determine the probabilities and percentile of the continuous variables in the distribution. So that is what we call as normal probability distribution. So this is a normal probability distribution. Okay. So as you can see here, these are all the properties of the normal probability distribution. First and foremost, the mean is equal to the median, which is also equal to the mode. So if in case in a distribution, the values of the mean, the median, and the mode coincides with one another, then we have a normal probability distribution. So meaning the values of the mean, median, and mode lies along this line. at the middle. Okay? So aside from that, a normal probability distribution is also unimodal. When we say unimodal, it has only one mode. Okay? Another probability is that it is symmetric. When we say symmetric, if once you fold the curve or the normal probability distribution, what is in the left is actually an exact replica on the right side. Okay? Half kumbaga. Pag finold ninyo, half-half talaga. Walang lamang yung kabila, walang kulang yung kabila. Okay? Aside from being symmetric, it is also asymptotic. When we say asymptotic, as you can see on both ends of the tails, yeah, even if you want to extend this one, okay, the curve, this one, the curve, okay, when we say asymptotic, will never touch the x-axis. So this is our x-axis. Even if you will extend it further, it will never touch the x-axis, only approaching. That is what we call as asymptotic. So basically, these are the properties of a normal probability distribution. Okay? Aside from the fact that any probability is always equal to 1, meaning the area, the total area of this curve is exactly equal to 1. Okay? I'll clear first. Okay. What is this empirical rule? Empirical rule, or another term for that, is the 68, 95.2, 99.4, or 99.7 in some books. Rule. Okay? So how do we use this empirical rule? In order for us to find the area in a normal curve, since you know that a normal curve has a total area of exactly equal to 1. So being symmetrical, meaning half of the curve is 50% and another half is 50%. Okay? And you know that the mean, the median, and the mode is always at the middle. Okay? It divides the curve into 2. And then what is this 1 here and the negative 1? Okay? So meaning the distance of a certain score from the mean, 1 standard deviation from the mean to its right and 1 standard deviation to its left, the total area of the curve from negative 1 standard deviation to positive 1 standard deviation is 68%. So half is 34% and another half is 34%. Okay? Another thing, the distance from the mean to 2 standard deviation to its right is exactly 47.6% and 47.6% to its left, a total of 95.2%. So meaning the area of the curve from negative 2 standard deviation to positive 2 standard deviation is 95.2%. And the area from negative 3 standard deviation to positive 3 standard deviation is 99.4%, or again, in some other books, it's 99.7%. Okay? So some of you will ask, bakit po hindi siya exact na 100%? Again, one of the properties of the normal probability distribution is that it is asymptotic. So the 0.3 or the 0.6% is allotted on the 2 tails of the normal curve. Okay? Okay. So to clearly understand the normal probability distribution, here is an example. The scores of the senior high school students in their statistics and probability quarterly examination are normally distributed with a mean of 35 and a standard deviation 5. So meaning, for our symbol, the mu is equal to 35. Okay. because it's the mean. So that's the symbol. And the standard deviation is 5. So what's the connection of this mean and standard deviation in a normal probability distribution? Okay? Since we have here two questions in which we need to find the percent of scores falling between 30 to 40% and the scores that fall within the 95% of the distribution, we need to draw the normal probability distribution. Okay, so sorry for the drawing. Okay, so I'm trying my best to make it really a normal probability distribution. Okay, so assuming that this is really a normal probability distribution. So how are you going to plot your mean and standard deviation? Okay, so again, at the middle, it's the 35, the mean. Okay, and since the standard deviation given is 5, meaning the distance of each score from the mean is 5. So from 35, which is the mean, going to the right, what score must be on one standard deviation? So it will be 35 plus 5 is 40. And this is equivalent to one standard deviation. So on the other hand, going to its left, since you add 35 from 35, going to its left, you need to subtract 5 from 35. And the score, which is 30, falls on -1 standard deviation. Okay? And then the next standard deviation will be 40 plus 5. So the score here is 45, which corresponds to 2 standard deviations. On its left, we have 30 minus 5 is 25. Okay, sorry, 25. And that corresponds to -2 standard deviation. And then the last one will be 25 minus 5 is 20. In case there will be a score of 20, then it corresponds to -3 standard deviation. And to its right will be 50. Okay. So again, you need to consider the empirical rule or the 65, 90, 5.6, and the 99.4% rule. Okay. So how do we answer question letter A? Okay. Question letter A. Okay, what percent of the scores are between 30 to 40? So look at your normal probability distribution. So your 30 score falls here, which is -1 standard deviation, and your 40 falls here. So meaning for us to find the percent, that is the area of this curve from -1 standard deviation to +1 standard deviation, and that is actually 60. Yeah, the 68%. Okay, that's correct. Okay, the area and the curve is 68%. Okay. Next, answering question number 2. What scores fall within 95% of the distribution? So where is that 95%? Okay, let us go back to the empirical rule. Slide, where's that slide? Yeah, there you have it. The 95%, it's from -2 to +2 standard deviation. So in that case, referring to our illustration, what score falls from -2 standard deviation to +2 standard deviation? That is the score from 25 to 45. So if a student score falls between 25 to 45, meaning he is within the 95% of the distribution. Okay, So that's how we use the normal probability distribution. Any question on that? I hope you understand my explanation on normal probability distribution. Okay, so for your learning task number 4, so second task for this week is learning task number 4, which is what I have learned. Okay, so you need to completely answer this, show everything. If there is a need for you to draw a normal probability distribution, then kindly write it. Okay, so any other question? I hope not. So we'll proceed with week number 4. Okay, so for week number 4, we really need to understand and to always put in your mind the empirical rule that from -1 to +1 standard deviation, the total area of the curve is 68%. From -2 standard deviation to +2 standard deviation is 95.2%. And from -3 standard deviation to +3 standard deviation is 99.4 or 99.7%. And so for week number 4, we will be discussing modules 11 to 13, in which module 11 is entitled Identifying the Regions Under the Normal Curve Corresponds to Different Standard Normal Values. And these are the objectives. We need to use the z-table or the table of areas under the normal curve, sketch the normal curve showing the required regions of or areas, and identify the regions under the normal curve of different standard normal values. So, question, how do you identify the area of the regions under the normal curve? Of course, we need to use the areas under the normal curve or the z-table. So if you have a book on statistics, or actually you can search that online for the z-table. Okay, so if you have time, you can print out the z-table, because in the next discussions we'll be using that table. Okay. Okay, what is that? The z-table gives the area of any value of z from -3.99 to 3.99. So if you will take a look on the table, if you have searched the z-table online, the values range from -3.99 to +3.99. Okay. So here are the steps on how to find the area that corresponds to z value. First, you need to draw or sketch a normal curve and locate the given z value on the normal curve. So you need to draw the bell shape or the normal curve. Then you need to shade the region of the curve according to the condition of z value, whether it is below, above, or between, or to the right, or to the left, or within two z values. Then use the table of the area under the normal curve to find the corresponding area. Then choose the appropriate operation, whether you will use addition or subtraction based on your illustration on the normal curve. Okay. When the z value is to the left or any related terms like below or less than, so just write the value we obtained in step 3. So again, if the word is to the left, meaning whatever is the value in the table of z, that will be the area being asked. Okay? But if the word is to the right, or like above, greater than, meaning you need to subtract whatever is the value that you can find in the z table from 1. Okay? You will see later why. Next, when the shaded region is in between the two z values, subtract the biggest by the smallest value, or the bigger value by the smaller value obtained in step 3. So if there are two z values given, you need to look for their area in the z table, and whichever is the bigger, okay, or the smaller, whichever is the smaller, you need to subtract that from the bigger. Okay, so meaning in between two z values, there will never be a negative value or negative area. And then fifth step is you need to label the shaded region and draw the conclusion. So how do we do that? Let's say, for example, you're asked to find the area that corresponds to the left. Okay, remember the word left. Okay, of z equals negative 2.1. So as suggested on the steps, on the different steps, first you need to draw your curve or the normal distribution. Okay, and then you think that this one is the z equals negative 2.1. Since we are so if this is your z, this line corresponds to z, which is equal to negative 2.1, we are asked to find the area to its left. So this is the shaded region, right? So once you have drawn the area in the of z equals negative 2.1 from your z table. So from your z table, the first column are the z values. So look for 2.1. Okay? 2.1 is here. Okay? And since there is no next number, it means that the next number is 0. Okay? So meaning the area is 0.0179. So meaning this area corresponds to 0.0179 of the normal curve. Okay? So, but what if the z value corresponds to negative 2.65? So you have to look for the z value on the first column, which is negative 2.6. This one. Wait lang. Negative 2.6. And then, above that, okay, wait lang. Okay, ayaw. Let's make a circle. Negative 2.6. Ayaw ng aking annotation. Why? Okay. So you need to look for the column of negative 2.6 here, and then the 0.05 above. So here is the 0.5, and whatever is the intersection of that, I'll try. 2.6, ayaw pa rin. Okay. 2.6, the intersection of 2.6 and 0.05 is 0.0040. So that's how we use the z table. So what if the z value is negative 0.73? So look for negative 0.7 and the 0.03 above. Okay, here's the column for the 0.03. So its intersection with negative 0.7 is 0.2327. Okay, so I hope you know how to look or use the table. Okay, so that's how we find the area that corresponds to z value of negative 2.1. So again, with that example, we use the word left. Okay, next we have to find the area to the right of z equals 0.29. So remember the rule, if the word is right, whatever is the z table, the z value table, or whatever is the value of the z from the table, you need to subtract that from 1. Okay, but basically, we still need to undergo the first step, which is to draw your normal curve. So if we'll draw the normal curve, 0.29 is to the right of the mean. So assume that this is the 0.29, and we are asked to find the area to its right. Okay, so area to its right is being shaded here. Okay, so from the table, use the table. So look first for the first two numbers, the 0.2. 0.2 is here, and then the 0.09 above. The 0.09 and its intersection, there you go, the 0.6141. But remember the rule, whatever is the value in the table, you need to subtract this from 1 if we use the word right. Okay, why? Look at the table. Okay, you are just asked to find this area. But remember, the area of a normal curve is always equal to 1. So there is no need for us to use this part. So that's why we need to subtract the 0.6141 from 1 in order for us to get this area. So meaning the 0.6141 is this area, but since this is not being asked, we need to subtract that from 1 in order for us to get this shaded region, and that is 0.3859, meaning the area that corresponds to the right of z equals 0.29 is 0.3859. Okay, let's have the last case, which is in between two z values. Okay. Find the area between z equals negative 0.33 and z equals 1.25. So first, draw the table or draw the curve. I don't know if I have here the illustration. I think there's no illustration. Let's try to draw that. So normal curve. Okay. So z, assume that this one is z equals negative 0.33 and z equals 1.25. Ayaw niya mag-dot. Okay. Okay. So as you can see, from the table, this is the required region in between. Okay. So if it is in between, as suggested in the rules, whatever is the value of z equals negative 0.33, which is 3.3707, must be added to the value of 1.25. So 1.25, where are you? 1.25. Let's make use the, okay, 1.25. So get 1.2 and then the 0.05 by 0.05. So it's 0.8944. So get the value of the two. Wait. So that is 0.8. Okay. Wait lang. I'll make use of the text. For 1.25, the value is 0.8944 added to the value of for negative 0.33. It's 0.3707. So that means the total area is 0. Okay, sorry. As suggested from the rules, we need to subtract the smaller value from the bigger value. So this is not, okay, this is not plus sign, but instead we need to use minus sign. 0.89, what's our value? I'll show the next slide. Okay, it's 0.8944. Minus the smaller value. Okay, so meaning, so 0.8944 minus 0.3707, and you're correct. The area being asked is 0.5237. Okay, so I have shown you the three different cases. And again, if it is left, whatever is the value in the table, that will be the corresponding area. If you use the word right or greater than or above, whatever is the value from the table, you need to subtract that from 1. And if there are two z values, subtract the smaller value from the table to the bigger value. Okay, so I hope you don't have questions on that, because we will continue. Okay, so you can check this. Okay, next module is about converting a normal random variable to a standard normal variable and vice versa. So normal random variable and standard. So these are the objectives. Distinguish a raw score, and that is your x, and the standard. Okay, express the normal random variable as a standard normal variable z. So x, from x to z. Okay, and express standard normal variable z as normal variable x. So meaning we need to express from x to z and from z to x. And lastly, we need to apply the concepts of normal random and standard normal variables in solving real life problems. Okay. Learning task number 2 is entitled Fill Me Up. So you need to complete the table by referring to the formula z equals x minus mu divided by the standard deviation. Okay. Okay, you can solve it using the formula, just substitute. Okay, and you're okay. So I will leave that as your exercises. Okay, so what we did actually is known as the standardization. Okay, if in case there's a random variable x, for you to convert that using the z formula, the process is actually known as the standardization. That's why we have the standard random variable, or simply called z-score. A z-score is a measured value is away from the mean. The house spread na. And this is basically our formula to convert a random variable x to a standard normal variable z, where z is equal to x minus mu divided by the standard deviation. So you know all those symbols. Okay. So look at this one. Determine the z value for each of the following x values for a normal distribution with mu equals 16 and standard deviation 3. So remember the formula, it's x. So we'll have 12 minus 16, that is negative 4, divided by 3. So the z-score for the first one x minus mu, remember that, divided by 3 is negative 4/3 or negative 1.33. So you can use fraction or decimals. Okay, next, how about if the random variable x is 8? So again, using the formula, it will be 8 minus 16 divided by 3 is negative 8/3 or negative 2.67. Okay. Next, what about if x is equal to 22? So you'll have 22 minus 16 divided by 3 is equal to 2. So the z-score when x is equal to 22 is 2. And lastly, if the z-score is equal to 25, then it will be 25 minus 16 divided by 3 is equal to 3. Remember the definition? This is actually the distance. So this is score from the mean. Let's proceed to the next slide. Okay, I have here a real life problem, a real life example. A consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of the bulbs was 842 hours with a standard deviation of 90. One particular light bulb from the Dura Bright company had a z-score of 1.2. What was the lifespan of this light bulb? So as you can see from the problem, you have there a sample of 100 light bulbs mean life, which is 842, and the standard deviation of 90. Okay. Company had a z-score of 1.2. So meaning we need to find I don't want to annotate. Okay. Using the formula, then we will have this learning task number 3 na pala. Okay. So in order for us to solve this, we need to take note of the value of the mean, the standard deviation, and the z-score. So how do we solve for that? Anyone who wants to think or try solving it? Okay, I know you have all the idea. On how to solve this problem. And how do we do that? Of course, use the formula. I want the pencil one. Z equals X minus mu divided by the standard deviation. And what is being asked here? So since we have the mean, so this is the mu, 842, the standard deviation of 90, okay? The z-score of 1.2. So meaning, in order for us to answer what was the lifespan of this light bulb, X is being asked. So substitute the values, we'll have 1.2 equals X minus the mu, which is 842 divided by 1 point, it's 90. Okay, so how are we going to solve that? Of course, multiply the 90 kay 1.2. So 1.2 times 90 is 108 equals X minus 842. So para mapag-solo si X, on the right side, we need to transpose this negative 842 sa left side. And remember, in transposition, once it is negative on the right, pag nilagay na siya sa left, magiging na siyang positive. So from negative 842, naging positive 842 na siya, plus the 108, so meaning the life expectancy of the light bulb is 950. So if the lifespan of the light bulb is 950 hours, then it will have a z-score of 1.2. Okay? So I hope that is clear on how to use the formula for converting a normal random variable to a standard. Okay? So for your learning task number 3 for week 4, so this is your third activity. Okay? And next, okay, so this is the next module, which is entitled Computing the Probabilities and Percentiles Using the Standard Normal Table. Okay, so these are the objectives. Utilize the use of the table of standard normal distribution and compute the probabilities and percentiles related to a given z-score or normal random variable x, and sketch the graph of the normal distribution. Okay, so remember this example that we had? for our week 3. So we simply use the word to the left of z, which is equal to negative 2.1. In symbols, yan. So this is read as find the probability of z less than negative 2.1. Okay, so this is the conversion of the words we had with this example for week number 3. So how do we do that? So since from the table, this area corresponds to 0.0179, in order for us to find its probability, you can use this already or convert this to percentage by just moving the decimal point 2 places to the right. So thus the probability of z less than negative 2.1 is equal to 0.0179 or 1.79%. Very simple. Next, so this example, so how do we convert that into symbols? So the statement here is find the area to the right of z equals 0.29. So in symbols, we have find p, yeah, or find the probability of z greater than 0.29. So therefore, by looking at the table, since we have here the 3.3859, okay, sorry. So it's greater than, right? Okay. So no need to subtract. Why? Because this area corresponds to the area which is greater than 0.29. So the unshaded region, this one, corresponds to the area of Z, which is less than. Okay, that's why we don't have to subtract this. Wait lang. Ayan. Okay. Actually, what we had last with this example, but this is already the answer. We tried to subtract that from 1. Okay. So, and so for your last task for week 4, okay, this is your learning task number 4. Okay. You need to underline the appropriate response, whether it is to the left or to the right, based on the symbols being used for the probabilities. Okay. So to recapitulate what we had for the normal probability distribution, always remember that the total area of the normal curve is equal to 1. Then using the z-table or the table of areas under the normal curve, it contains the corresponding area of the z values. And these are the steps. First, you need to draw or sketch a normal curve in order for you to locate clearly where is that z value and the area being asked. Then you need to shade the region, use the table for the area. If the word left is being used, whatever is the value in the table, that will be the answer already. If you use the word right, you need to subtract the z table from 1. And if if you use the word between, the smaller must be subtracted from the bigger. Okay. And for the last one, in order for it to convert a normal distribution, we need to use this z-score formula, where z is equal to x minus mu divided by the standard deviation. Okay, so I hope modules from 8 to 13 are very clear now to you. Thank you, everyone. Have a good day, and I hope I was able to impart something from the discussion for weeks 3 and 4. Goodbye, everyone.